Hey guys, in this video we are gonna go through this Leetcode number 2, add two numbers. So basically this is a linked list exercise. So this question was very popular. You can see that many people has already liked it, and it was asked by so many different companies, big names. And so let's take a look at the question. So we are given a two non-empty list representing two non-negative integers. The digits are sorted in a reverse order, and this is actually pretty convenient for us. And each of the nodes contain a single digit, add the two numbers, and return the sum as a linked list. And we can assume that the two numbers do not contain any leading zero except the number zero itself. So let's take a look at this example here. 243. That is representing 342 actually. And 564, and this is representing 465. And then the sum of that would be 807. And this number are represented by a linked list as stated in the question. So a linked list means that this is a singular linked list, means we have a head node, and then links to the next node, also links to the next node after that. So the challenge for using a linked node is only going to one direction, right? We can only go from this direction to this, and from here to here. It's only going to one direction, and there's no way to go back. And also, we don't know the length of the linked nodes ahead of the time until we traverse to the end of the linked node. So let's take a look how we can solve that. We have a dummy head, and that is a linked node. So the reason why we need a dummy head is we can grab the head. So essentially, the next of the dummy head is the actual head that we will return. That's why we need a dummy head to grab to save the actual head, so we can return it at the end. Because the name list is traversed only one way. That's why we don't want to go all the way back to the front. That's why we just grab the head. So we have the given two linked list, looks like this. So we have a carry. Carry is the number that we will carry in the next digit. Let me sum it. Next position. So basically, if we have 4 and 6, right? If we 4 plus 6 equals to 10. So 1 will be the carry, and then we'll go to the next position. So that's why, so initial carry will be 0. And then basically the current sum is equal to, so while none of them are not none. Sorry, let me zoom it. So while none of them are not none, so means that both of them has value. The current sum equals to the L1 dot value and plus L2 dot value plus the carry that we have previously. So in the beginning, so there's no carry, that's why it's gonna be 0. And the remainder is gonna be a modular of the current sum out of 10. And then we create a new linked node. So basically, I call it like a temporary node, and the value for the temporary node is equal to the remainder. Because let's say it's 4 plus 6, and take the modulo of 10 is gonna be 0. So that's why the remainder is exactly what we need to assign to the current temporary node. And also then the current node dot next is gonna be equal to the temp node. Basically, we are passing along the newly created temporary node to the current node that we will be returning at the end. And also the next carry is equal to the current sum and and double slash of 10. So in Python, double slash means it's going to be a remainder. Sorry, double slash should be called a floor division. So let me show you what I mean by that. So let's say we given the x is 15, and the y is 2. So 15 floor division of 2 is going to be equal to 7, because 2 times 7 equals to 14, and the modular will be 1. Okay. So the remainder, I call it in my code, I call it remainder, is going to be equal to 1, and this floor division equal to 7. And this is exactly what we need for the next carry. So and then we move to the next current node by using this. So current node equals to current node dot next, and also we move for the L1, and also we move on for the L2. And if in a case where we made a node is equal to none, so why we need that? Let me show you why we need that. I think it's easier to show an example. So this is a perfect example to show you why we need that. So you can see in a case where there is just something in the L1, but there's nothing else in L2 when we are at this point, right? So that's why I call it remain node. So in this example, there's nothing in remain after we finish this while loop, because everything's coming to a pair, right? So this one corresponds to this guy, and this one corresponds to this guy, and this one corresponds to that guy, and then this one works out perfectly. However, in a situation where one of the linked nodes is longer, like the one in here, so the L1 is a lot more digit than the L2. In this case, we create a new variable named remain node. So if L1 is none and L2 is not none, and the remain node will be L2, and the other way around. Basically, it's grabbing the first non-none node in the longer linked list. Basically, this is what it is. And while there is something in the remain node, and we need to put in the current sum. So the current sum equals the remain node value plus the prior carry, and then the remaining code is pretty much the same as the one we saw before, right? So we look at the remainder, look at the modulo of 10, create a new temporary node, and then assign it to the next node, and take the floor duration, and then move along for the current nodes, as well move along for the remainder nodes. So it's pretty much identical to what we went through before. And this part of code, what we need that is, remember when I run this, I had this guy commented out, and as you can see, the output, my output compared to the expected output, there's 1 digit short. And the reason is because after we add it all together, and there's still something in the next carry. So in this case, the next carry is going to be 1, and we have to capture the last digit for the prior carry, and we have to create a new temporary node, and that value is directly equal to the prior carry that we finished all the prior calculation, and then we push it to the current node. So current node dot next equal to the temp node, and at the end we're going to return the dummy head dot next, because again the dummy head just want to grab the real head, the actual head. Okay. And we can run that, and it's going to work. Okay, it looks okay. So in terms of time complexity, it is big O of n. So basically, we're traversing all the possible nodes between L1 and L2. So the official solution says big O of maximum of m and n. So m and n is representing the length of the L1 and L2. And for space complexity, it is just because we have to create a newly created node, like this one, right? We have created a new linked list, and that's exactly what it's saying over here. So that text space. So yes, so this is my solution to this problem. I hope you like it. If you do, please like this video and consider subscribe to the channel. That will be huge encouragement to me for future videos. And thank you for watching. I will see you in the next video.